Hey everyone, today we're jumping straight into a hyper-focused explainer on a really fascinating quirk in analog electronics. We're looking at the unity gain paradox, and by the time we're done here, we're going to completely demystify the voltage follower circuit. Okay, let's dive into this. Here's the central paradox for today, the real head-scratcher. Why on earth would an engineer deliberately build an amplifier circuit with a voltage gain of exactly 1? I mean, amplifiers are supposed to, amplify, right? So why build one that literally just spits out the exact same voltage it takes in? Well, the foundational math behind the voltage follower, which you'll also hear called a unity gain buffer, is honestly incredibly simple. The output perfectly mirrors the input. Vout equals Vn. Done. But to actually get why this 1-to-1 ratio is so ridiculously useful, we need to look at how it's wired. And this brilliantly illustrates the secret. It's an elegantly simple closed-loop feedback design. We take an op-amp, feed our input signal directly into the positive non-inverting terminal, and then we literally just loop the output right back to the negative inverting terminal. That's it. There is absolutely zero resistance in that feedback loop. So how exactly does this solve our paradox? It all comes down to impedance. Actually, think of the voltage follower like a nightclub bouncer. At the input, it's got this incredibly high impedance. It draws almost zero current, just microamps, which completely protects your fragile source signal. It lets that exact same VIP signal through to the output, but, and here's the kicker, at the output, it has very low impedance. It provides this massive electrical muscle, giving you the current to drive heavy loads without ever dragging down or collapsing that fragile original source. Because of this whole bouncer effect, these little circuits are absolute lifesavers in the real world. We use them for isolating delicate filter stages from one another so they don't interact. They perfectly prevent nasty loading effects that would otherwise totally distort your signal. Plus, they're absolutely critical for driving analog to digital converters, since those demand sudden bursts of current to charge their internal sampling capacitors. And, of course, they act as the ultimate impedance matching network. Which brings us right to our final aha moment. While a voltage follower might have a voltage gain of exactly 1 because it pulls virtually zero current from the input but can supply massive current to the load, well, its theoretical power gain is infinite. It doesn't amplify voltage, its true superpower is power amplification. Crazy, right? And that leaves us with a question to ponder. What fragile signals in your own circuit designs are just waiting to be empowered by a simple buffer?